Okay, so now we're going to be doing combinations of some items. Some kind of quotes, that's going to be the key thing here. So I've pre-written the example. You have an apple, a grape, a kumquat, and a banana, one of each. One grape's not that exciting, I guess, but you have one of them. You are packing lunch. How many different lunches can be packed? So what we could do is we're going to have some cases here. So what we could do is we could say, okay, we're going to pack, so we could pack 4 fruits in our lunch. Because notice the problem didn't actually say how many fruits we're packing in this lunch here. So we could pack 4 fruits, or 3 fruits, or 2 fruits, or 1 fruit, or 0 fruits. So that's what we could pack in our lunch. And if we're going to pack 4 fruits in our lunch, so we have 1, 2, 3, 4 to choose from. If we're packing all 4, then the order we're doing it doesn't matter here. So that's just going to be 4 choose 4, which would be 1. And for 3 fruits, it would be 4 choose 3. For 2 fruits, we have 4 and we're choosing 2 of them, choosing 1 of them, and choosing none of them. If you put in the calculator, you would find that there's 4 ways to choose 3 fruits. Essentially, we could choose 1 fruit to leave out. 6 ways to choose 2 fruits, 4 ways to choose 1 fruit, and 1 way to choose no fruits at all. Which means, if we look at it, that there is 1 plus 4, 10 plus 10, 16. There are 16 different lunches that we could pack. So 16 different lunches to pack. Now, one of these lunches though, one of these lunches that we're packing is this super lame no fruit lunch. And so, depending on how we're feeling, we may actually say -1, which would give us, is this visible at all? I should probably use this color. Right, so this should be maybe -1, which would give us 15. So what we have is we have 60 lunches, -1 maybe, which would leave us with 15 possible lunches. We're going to call this 0 fruit lunch, we're going to call that, we're going to have a mathy name for it actually. We're going to call it the null set. So the null set is going to be the set of no objects, which sometimes deserves to be counted, and sometimes deserves not to be counted, depending on the question. So the answer is 16 -1 maybe, which is 15. Okay. We're going to take the exact same question, but we're going to solve it in a different way this time. So what we could do instead of listing all the cases is we could say, okay, we're going to make a tree diagram. So we have an apple. Now what we could do with the apple is we could either take it or not take it. So we could either have an apple or no apple. And then with the grape, we could kind of do the same thing. We could either have the grape or no grape. And if we didn't take the apple, we could take the grape or no grape. And with the kumquat, which by the way is a type of fruit, we could either take the kumquat or not take the kumquat. Kumquat, no kumquat, kumquat, no kumquat. I'm not going to write the next one out fully. And then finally, we have a banana, and we could either have the banana or not have a banana and do it for all of those choices. I'm going to write this one also for reasons. So we could have a banana or not have a banana. And so we want to figure out how many different lunches we could pack. It's a tree diagram. And we have 2 options, 2 options, 2 options, and 2 options for a total of, and these are going to be multiplied, for a total of 16. But one of those 16 options is the super lame no apple, no grape, no kumquat, no banana. which means what we're going to do, it's going to be 16 minus 1, maybe, and it's going to be 15 possible lunches. So there's two ways of doing that. Okay. Next example, you can pause the video and write it out. You're making a bouquet of flowers. There are 4 roses, 3 daisies, 7 chrysanthemums. I will freely admit that I actually looked up how to spell that, but it's a nice word. And 1 orchid, because those things are expensive. A bouquet of no flowers is ridiculous, so we're not going to consider that to be a bouquet. How many different bouquets can be made? Okay. So we're going to do the tree diagram technique. But this one's going to be a little bit different. So the roses, what we have here is we have 4 roses and they're all identical, and the daisies are identical, and the chrysanthemums are identical to each other. So now we're doing combinations of some objects where some are identical. So what we're going to say is, we're going to say, okay, with the roses, I could either get myself 4 roses, or 3 roses, or 2 roses, or 1 rose. Or actually I have another option. I could also have 0 roses. So overall we have 5 options, right? And then our next thing, we have 3 daisies. So what we could do with the daisies is we could have 3 daisies, or 2 daisies, or 1 daisy, or we could have no daisies as well. And then chrysanthemums, we have 7 of them, so we could have 7 chrysanthemums, 6, 5, 4, 3, 2, 1, or 0. Lots of options for the chrysanthemums. And then for the orchids, we could either have 1 orchid or no orchids. Man, I should not have used orchids. So if we look, what does that mean? It means that over here we had 5 times 4 times 1, 2, 3, 4, 5, 6, 7, 8 times 2. And that is going to give us 2160, 320. It's going to give us 320 options. Now, of course, one of those 320 options is the 0 rows. Why do I keep on going to that color? 0 rows, 0 daisies, 0 chrysanthemums, and no orchids. So that's the no orchid thing. So of those 320, one of them is having nothing. So we would subtract 1 and we would get 319. So it would be 319 bouquets we can make with these flowers. Now I'd like to point out that 5 was really 4 plus 1, and this was 3 plus 1, and this was 7 plus 1, and this was 1 plus 1. And if you look at the options, right, so we had 4 roses, which meant we had 4 plus 1 options for the roses. 3 daisies, so 3 plus 1 options for the daisies. 7 chrysanthemums, so 7 plus 1 options for those. And there you go. And that's how you do the bouquets.